We all know that metals are excellent conductors of electricity. They can be used to complete a circuit to allow electricity to pass through them, lighting up the light bulb. This is because metals that are solid have their atoms arranged in nice rows and columns called a lattice. The atoms of a metal all give up some of their electrons to their neighbors to attract the other nuclei. These electrons form a kind of sea of electrons around each atom. And as they are allowed to move freely from one atom to the next, they allow electricity to pass between them when a circuit is completed. If copper metal comes in contact with chlorine gas, it produces this cool-looking blue compound, which does not conduct electricity. You might also be under the impression that water conducts electricity. However, pure water, distilled water, does not conduct electricity either. However, if we combined the two, water and our copper and chlorine substance, they do conduct electricity. So there must be some part of this compound formed from copper and chlorine and something to do with water that allows electricity to pass through this solution. If we pass a current through the solution, we can actually force it to separate into two parts. At the positive end, at the cathode, we see bubbles start to form. We can capture those bubbles, and if we were to smell them, they would smell a lot like a pool. At the negative end, or the anode, we find a solid beginning to form that looks a lot like our solid copper that we started with. So what does this tell us? The copper must have formed something positive since it is found at the negative end when they separate, while the chlorine must have formed something negative since it was attracted to the positive end of our electrolysis. These charged atoms are called ions. The positive ions are called cations, while the negative ions are called anions. It is possible to predict the charge of an atom based on its electron configuration. Looking at a neutral atom of lithium, which only has 3 electrons, we find that its electron configuration is 1s2, 2s1. Now recall that the noble gases have the least energy of all the elements on the periodic table. They are inert or stable. This is because of their full valence shell, which has 8 electrons in it. Atoms will gain or lose electrons to have configurations like the noble gases. This is called the octet rule. It's like forming a group for a project. If I say you have to work in groups of 8, lithium is either 7 short of having a full group, to be like neon, or has 1 too many, to be like helium. So, will it be easier for it to find 7 people to work with, or to lose 1? Obviously, it's easier to lose 1 electron than it would be to gain 7. And since electrons are negative, the loss of 1 causes lithium to gain a +1 charge. So lithium becomes a +1 cation. The same holds true for every member of the alkaline metals, group 1. They all end in some number S1. Therefore, they all form a +1 cation. Group 2 all end in some number S2. They are 2 electrons away from being a noble gas, and therefore they all form a +2 cation. In group 13, boron and aluminum end in some number S2, some number P1. They will lose 3 electrons to become a +3 cation. Beyond group 14, the situation changes. So let's look at a halogen, fluorine. Fluorine's electron configuration is 1s2, 2s2, 2p5. It is short 1 electron from being like a noble gas, neon. Therefore, fluorine, rather than lose 7 electrons to be like helium will gain 1 electron to be like neon. And since electrons are negative, fluorine becomes a -1 anion, which changes its name to fluoride. Anions with only one element in them all get the suffix "ide", I-D-E. Again, the same situation holds true for every member of the halogen family. All of them end in some number S2, some number P5, and therefore are all 1 electron short from being a noble gas. Therefore, they will all form a -1 anion. The nonmetals in group 16, oxygen, sulfur, and selenium, are 2 electrons short of being a noble gas, and therefore will gain 2 electrons, forming oxide, sulfide, seleniide. The nonmetals in group 15, nitrogen and phosphorus, are 3 electrons short of being a noble gas, and therefore will form the anions nitride and phosphide. Now you might be asking yourself, what about group 14, or all of the transition metals? Well, we will spend an exorbitant amount of time on group 14 in of itself, and the transition metals do very weird, very different things, depending on what they're bonded with, or how they were put together. Therefore, for right now, we're going to ignore the transition metals and group 14. So back to what we saw in the experiment. Our blue powder, which we knew was a copper and chlorine substance, did not conduct electricity, even though copper metal does. So what prevents the copper chloride substance conducting electricity? It must be the chloride ions. Metals conduct electricity, non-metals do not. But when an ionic compound, which contains metals and nonmetals, is dissolved in water, the metals separate from the nonmetals and are able to conduct electricity again. We call these electrolytes. And since our substance was formed of 2 ions, a cation and an anion, we call this an ionic compound, and it is held together by the electrostatic force of a positive ion attracted to a negative ion.